never use anything other than quality of service 0 for command and control. It's really the kind of the premise of MQTT is that we're simple, efficient, bidirectional, stateful, open, and then I'll get to the security part later. Could we do pub sub over VSAT? So literally, I always give Steve Koenig the credit for being really the genesis of MQTT. 2025, guess what? That's a zero trust security scheme.
First of all, I just want to thank everybody for attending. It's a great opportunity. I'm going to give as much time as we can to Arlen Nipper. My name is Mike Flores, and I work on the with OpSite Energy and the IDM team. And I think right now CNX has found its way, whether accidentally or not. I think there's lots of intention into what we're going to use the term digital transformation. I know that's a coined word that gets tossed around a lot. But one of the key things here is that the minute that, or the time that CNX said, hey, we want to deploy a brand new ignition platform, it sets you up for some quick digital transformation in the organization. Maybe not quick in terms of time, but quick in terms of its deployment, its capability, and the ability to see some optimization in what CNX is doing. The good news is that CNX isn't alone in what it's doing because you have lots of different, your competitors are doing the same thing, whether it's here in the Appalachia or in other oil and gas plays. Ignition is one of the more popular choices for digital transformation, but one of the unique things is its ability to serve as an IoT middleware product that has lots of native connectivity and capability in the field, but at the same time, it's quick deployment to take the product and move that to the cloud. And I think we have a really good opportunity here to listen and participate with Arlen Nipper. I had the chance to meet Arlen a few years back at the Ignition Oil and Gas Conference, and that's a group of your peers that actually meet, that have Ignition deployed. And I was looking for a tool, an aggregation tool for data, and at that time we were looking at HiByte and lots of different products, and Arlen came up to me and said, wait, hold on, time out. Before you do that, let me show you something. And that kind of spawned lots of conversations, and that led us to, when I was over at Howard Energy, the deployment of a half dozen Ignition setups there for their digital transformation that moved them and propelled them towards lots of integration projects and improvements at Howard Energy. And since then, you know, I've just seen lots of explosion and growth with MQTT and lots of the things that we're going to talk about today. So Arlen's going to present, and then we'll do some Q&A. And what I'm asking for is just a really good open mind about what we're doing here. And the hope is that this gets us all kick-started on a journey towards some transformation inside the CNX organization. And it's good to see a spread of not just CNX, but also the leadership team at CNX. So with that, I want to introduce Mr. Arlen Nipper. Thank you, Arlen.
Thanks, Mike. Appreciate it. So hello, everybody. My name's Arlen Nipper, and I'll kind of go through a little bit of my background. I guess I've only been doing industrial automation, SCADA, network infrastructure, whatever you want to call it, for almost 47 years now. So I'm not very smart, but I've been around a long time. So, so kind of where to start off with is kind of who is Cirrus Link? What do we do? You know, what is it? So in 2012, I had the opportunity to start a new company. And 26 years ago, Andy Stanford Clark from IBM and I had co-invented MQTT. And we did it for Phillips 66 pipeline. It was great. So MQTT was out there, but as I watched it, it was like MQTT invented for OT, hijacked by IT. So if I looked out there, I saw AWS had MQTT, Azure had MQTT, Google Cloud Platform had MQTT, but it really wasn't being used much in operational systems where we actually had intended for it. So we started Cirrus Link. Now, we knew we weren't going to do an entire industrial application platform. So 2 years later, we got very fortunate, and we are the only strategic partner with inductive automation. So that means what we do 8 hours a day, 5 days a week, is we just work on MQTT technology that runs on the Ignition platform, that leverages it, and then gets that information out using MQTT and a standard that I'll be talking about called Sparkplug. So these are some of the modules that we've developed over the years. I don't know if this is going to work. Oh, well. So MQTT engine, distributor, transmission. We do some injector products that inject data into some of the cloud platforms. And then we have a standalone Chariot MQTT server. So that's what Cirrus Link does as a business. That's how we make our money. So a little bit about my journey is that I graduated from Oklahoma State in 1979. I was an electrical engineer. But before that, I guess about 2 years before that, I'm going, man, electrical engineering is boring. I'm out of here. So I'm walking up to my advisor to say, I'm quitting. I want to go do something else. And there was a job posting, and it said summer intern for Amoco Oil in Tulsa, Oklahoma. That was before it was BP Amoco, but the Amoco was silent now. So I got there. The supervisor for the engineering department said, hey, Arlen, we've got this brand new department started over here. It's called our microprocessor R&D. And that summer, I literally got to wire wrap a RCA 1802. It was the first CMOS microprocessor. It ran at 200 kilohertz, and it had 256 bytes of RAM. And I got to write machine language, burn an EEPROM, plug it in, and if you don't, an EEPROM is basically you would burn your binary onto it, and then you would plug it in and see if your program worked. And if it didn't, you had to take the EEPROM out and put it under an ultraviolet light and erase it, and then program it again. So the ultimate in cybersecurity, actually. But anyway, after that summer, I know, man, this is exactly what I want to do. So I went back to Oklahoma State, pretty much dropped analog courses, got a minor in computer science, and kind of that's where I went from. Now, that is an EEPROM. So that you would burn your program, your binary data onto an EEPROM and plug it in to the system. That's wire wrapping. So you literally had posts coming out of the bottom of the circuit board, and you would take like a knitting tool and you would wire around each pin, and you would literally wire up your circuits like that. And that is my first home computer. It was a ELF computer. It ran an RCA 1802 microprocessor. You would input your program through the hexadecimal keypad. So anyway, so literally I grew up in Medford, Oklahoma. So I knew the guys at the Coke refinery in Medford. So got out of college. I went to work for Coke Oil. I got there the first day. I said, what do I do? And they said, well, we don't know what engineers do. Why don't you just go out in the field and start doing stuff? So Medford, if you aren't familiar, the refinery in Medford basically brought in raw feed from all of the gathering plants. We brought that all into Medford. And the reason it's in Medford is we had salt caverns or salt underneath Medford, and we would wash out the caverns where we put the raw feed in, fractionate that purity product, ethane, butane, isopentane, propane, and we would put that down to the caverns. Well, then the ethane market in Mont Belvieu exploded. So the Koch brothers decided they wanted to build 2 8-inch pipelines from Medford, Oklahoma to Mont Belvieu, Texas in 1 year. So with that, I got to do everything. I got to run the ditch witch, put the conduit in the ground, learned how to hook up a 5,000 horse Westinghouse electric motor, connect that to a centrifugal pump, bring all that back into Toshiba, made the dog houses for us. And inside the doghouse, they had the brand new vacuum tube starters instead of the old oil wetted contact starters. That's a Toshiba vacuum tube starter. Then I got to learn how to program a Modicon 484 PLC. That is about the size of this podium here. It was one of the first PLCs that came out. And remember, 2 years before that, they had invented a protocol in 1978 called Modbus. And now here we are, 46 years later, and Modbus is still the most used protocol in the world. So kudos to the guy that invented Modbus at Modicon. Then, pretty cool, I got to learn what a 4 to 20 milliamp transmitter is. I got to learn how to hook it up. Why do we have 4 milliamps? Right? Can't figure that out. Well, why don't we just have 1 to 5 volts? Well, and we've kind of forgotten why we did 4 to 20 milliamps. Well, the reason you've got 4 milliamps is when a bulldozer cuts that wire, your 4 milliamps drops to 0, and all of your emergency shutdown can happen. So if you're on a 1 to 5 or 1 to 10, you can't do that. You don't have any safety control over the wire. So even with all the advancements in technology, today we still have 4 to 20 milliamp. But now I'll go into this more in detail later, but we have smart 4 to 20 milliamp transmitters that we really should start taking advantage of that we're not today. So I learned what is zeroing a transmitter, spanning a transmitter, dampening the factor in the transmitter, get that 4 to 20 milliamp into a PLC, raw value of 0 to 1024, scale the value 0 to 1024 to 0 to 100 PSI, and hope that we get all of that typed in manually correctly, because if I had a 0 to 100 PSI transmitter, but I scaled it 0 to 1,000, and we're controlling a pipeline on that, that's not good, right? Now, the other thing that, if you look at that, that is a Fisher control valve. And we had Fisher control valves on the suction side of the booster. We had on the discharge side. And I learned what a PID loop was, where you would control on suction pressure until it was satisfied, and then you would control on discharge pressure. And I learned how not to do a PID loop when it's running, and I've got a Fisher control valve there slamming up and down, and you could actually feel the ground shake as I tried to tune a PID loop. So kind of, PID by emergency. So that is a FSK modem. So 300 baud, and it would modulate data by putting a sine wave on a wire, and that's how we ran the pipeline. So that is a PDP-11. So from Medford, Oklahoma, we were controlling about 2,000 miles of pipeline, and it was all AT&T multi-drop circuits. So literally from Medford, Oklahoma to Mont Belvieu, Texas, we had 4 copper wires that were ours. And we would run those to a 300 baud modem, and that modem then would connect to our RTU, and the RTU connected to the PLC. So the PDP-11 in Medford would send a pole command out onto the 4-wire circuit. We had, 50 booster stations. The RTU were listening for their address, and if they heard it, then they would respond to that pole. So anyway, 7 years at Coke, and I still today, probably everything I know about controls and engineering and instrumentation, I learned at Coke. It was a great experience. Then after that, while I was at Coke, I got really interested in smart transmitters. So Honeywell in, I think, 1985-ish, came out with the first smart 4 to 20 milliamp transmitter. And the way it would talk is it would bang the 4 to 20 milliamp at 218 baud. But it could do that because your analog input circuitry on your PLCs has a 3 hertz filter on it, right? So you could literally start banging digital data on the 4 to 20, but still actually would average out to the 4 to 20 milliamp value. So in my bedroom at home, I invented it was called Honeywell ST3000, and I invented an ST3000 multiplexer. And Honeywell was very interested in that because I could multiplex up to 16 of these smart transmitters into one digital stream of data that you could talk to at Modbus. It was really cool. You could pull at Modbus, and you could get all of your digital values from your Honeywell smart transmitters. So Honeywell was very interested in that. I moved to Kansas City from Medford and started Arcom Control Systems. And at Arcom, basically, we did single board computers. But I found it very hard to sell single board computers. You go in, it's a green circuit board. There it is, and you would try to sell it, and the customer would go, well, Arlen, what's that chip? Well, well, how much does it cost if you take it off? Right? And what about that chip? And what I'm saying is, it was very hard to sell, single board computers. But if you put them in a container and did a protocol converter, guess what? You could charge a lot of money for it. So taking the experience that I had from Coke, we had Tano protocol, we had Modbus protocol, we had BSAP protocol. I had already dealt with all of these protocols, and at the time, a lot of major midstream pipeline companies they had gone all the way back into probably the early 72, 73. Now they had a lot of legacy equipment in the field, but they wanted to put in newer equipment, but still use their old SCADA system. So we did protocol converters. So we would go out in the field, drop in a Arcom director, and it would talk the native protocol, and then we would convert that to Modbus and go back to a more modern Modbus SCADA host system. And that worked very well. In the late 80s, early 90s, we probably had 70 to 75% of all of the midstream pipelines were using Arcom protocol converters. So, kind of at that time, this is my world. This is SCADA pole response protocols. And if we look back now, and if any of you are in digital transformation or trying to modernize the SCADA system, and somebody looks at you and says, well, what's the problem? Why can't you get that data? Why can't we speed this up? This is the problem, right? We have 45 years of this mentality of having to poll a piece of equipment. So poll, get a response back. Poll, get a response back. Now, if you're on VSAT or if you're on cellular, that will guarantee you're consuming 100% of the bandwidth that you have. Think about it. I've got a circuit, and I am totally saturating it because I have to poll everything to know what the state is. So if I poll one of your booster stations and the valve is closed, and then I go to the next one and poll it, and then the next one and poll it, well, hang on. What happened over here with that valve? I mean, I've got 10, 15 minutes that I don't see what's going on there. So all of this nice 4-wire circuits, it was great. It actually did work very good. So we upgraded. We ultimately got to 2400 baud modems. It was great. I could call Toll Test in Oklahoma City, and they would immediately help me troubleshoot my circuits, all of that. But as AT&T got deregulated starting in the mid mid to late 80s. By the mid 90s, that means that all of those phone companies that were AT&T were now local. So now, if I had a problem at Conroe Booster Station, I had to call Conroe Public Telephone Company, and I was lucky if they knew what a modem was, let alone if they could help me troubleshoot it. So really what happened is that whole four-wire infrastructure, they were heavily subsidized. I can remember at Coke, we had a tank farm in Stockholm, Oklahoma, and they had to run 27 miles of four-wire circuit. But they did it because they were subsidized to do that. So as all of that infrastructure really started crumbling down, we had the VSAT vendors come around. Galat, GE SpaceNet, Scientific Atlanta, AT&T tried them. And what the VSAT vendors came in and said, hey, look, we've got a solution for you. We can put a small, very small aperture VSAT, very small aperture dish in the booster station. You can connect your equipment to the indoor unit, and that data will go over the bird, down to a ground earth station, and then back to your SCADA system. And, oh, by the way, all of the VSAT companies had a proprietary protocol to get the data over the VSAT. So now we're kind of in a catch-22. Our protocol converters had to convert legacy SCADA protocols into newer protocols. Then we had to implement the protocol to get it over the satellite network and then get that back at the other end and then spoof Modbus at the other end. So again, we made good money. We sold thousands and thousands of protocol converters. But something happened in the late 1990s is that Steve Koenig was a very good friend of mine. He was a SCADA manager at Phillips 66. We had thousands of protocol converters for them. They were running everything over Galat VSAT and Scientific Atlanta and AT&T. And one day in 1998, AT&T came out and said, hey, we've got a new transport protocol. It's called TCP/IP. Now, I say that, but do you realize, for me, in the 1980s and 1990s, if you were doing oil and gas SCADA, you were running DEC computers, and you were running DECnet networks, or you were running IBM networks. TCP/IP had just came out. So today we look around and go, Arlen, what's the problem? TCP/IP is ubiquitous. But it wasn't in the late 1990s. Now, Steve, again, VSAT bandwidth was expensive, terribly expensive, to the tune of $500,000 to $1 million to $2 million a year just for utilizing your VSAT. And remember, I told you that if you're polling over a satellite, well, first of all, you got propagation delay, right? So you got 500 millisecond propagation delay up, out. So basically, you got around 2 seconds of delay from your poll to when the response comes back, and then you're going to the next. So you're burning 100% of your space segment that you had on that VSAT. Literally 100%. So Steve said, hey, you know, Arlen, there's got to be a better way to do this. Now, I've got a friend, Steve did, he had a friend in IT, and they were using IBM MQ series. And he said the new technology in IT at the time was called message-oriented middleware. So IT, when they, historically, they would write a legacy application, and then all of the other applications would interface to it. And if they changed anything, they had to go rewrite all the clients that utilize that application. But when they came out with pub/sub, that means that you could write one application and it would publish information, and another application would subscribe to that. And so you could change. Now you've decoupled those applications, and it's publish and subscribe. So Steve said, hey, Arlen, I like that. Could we do pub/sub over VSAT? So literally, I always give Steve Koenig the credit for being really the genesis of MQTT. Now, at the time, unbeknownst to me, I just want to throw this slide up. This was in 1997. A research scientist in Hursley in the UK for IBM came up with this diagram. And the emerging industry, I love this slide because he's got message broker, he's got data warehouses, he's got SCADA, he's got telemetry, and his vision was, hey, we could use the same pub-sub architecture and we could expand it out to all of these applications in the world. So they hooked me up with Andy Stanford Clark. So Andy was a IBM intern at the time, but he had been working with MQ series. He knew all the IT side. So basically, Steve Koenig was talking to IBM. IBM said, hey, we think we can do pub-sub. Let's get Andy over there. So literally, Andy and I sat in an office at Phillips 66 Petroleum and said, okay, let's take Big MQ and start with that. Now, Big MQ probably had a 5,000 byte header just to get messages started. And we looked at it and go, that's probably not going to work, because our formula was that every byte that we could save on the wire was going to be another $50,000 a year in cost savings for Phillips 66. Every byte that we saved was going to be another $50,000 a year. So we got together. The IBM marketing department's not very good. So first it was going to be called OTWP, and then MQI SDP, MQ Integrator SCADA Device Protocol. And then we thought that was too long. What about MQ Integrator Pervasive Device Protocol? Anyway, it ended up being MQTT. And today, when people ask, what does MQTT stand for, really, it's just MQTT. But at the time, it was using some of the IBM MQ series technology. So our Archon protocol converters were basically 8-bit Z80s. We had 64K of memory. Embedded TCP/IP stacks were almost unheard of. So the first thing is, this thing had to be simple. It had to be efficient. Every byte that we saved was going to save Phillips 66 a lot of money. It had to be bidirectional, right? We couldn't just be publishing information. We had to send commands out to the field, so it had to be bidirectional, and it had to be stateful. And by state, that's the interesting thing for me for TCP/IP and MQTT. So if I take a typical SCADA system today, a polling system, and I'm sitting there, the way that I maintain state is I keep polling. So I'm polling one of your booster stations, motor's running, come back. Well, now I don't know what it is, so I'm going to have to poll it again. Is it still running? I come back, I'm going to have to poll it again. Whereas if we had state with MQTT, if we were stateful, we could come up, publish everything, publish all of our process variables that are at a booster station or at a remote site. And then once we had state, we knew we could do report by exception. Okay? That's at the time, and even today, a lot of PLC programmers and stuff really don't understand that you don't have to poll. With TCP/IP, it's perfectly legal once you have a connection to just publish a piece of information. So that's really the kind of the premise of MQTT, is that we're simple, efficient, bidirectional, stateful, open, and then I'll get to the security part later, because guess what? 1998, nobody asked us about security. Hey, it's obscure, it's on our own network. Don't even worry about security. It's not a problem. So I'll get to that in a second. So we did base everything on top of TCP/IP. a lot of people said, "Oh, Arlen, Andy, you should use UDP." If we would have used UDP, we would have invented a bad version of TCP/IP. And again, no. So the premise was at Philips, we took those Archon protocol converters out in the field. We put an MQTT client in them. We had a broker. The IBM MQ series broker was sitting in Bartlesville, Oklahoma, actually 6 of them. So basically, when the system came up, you'd turn on everything. The SCADA system was basically quiescent. The units out in the field would poll everything that they're supposed to, all of the PLCs, all of the flow computers, all of the Heart Smart transmitters. Then they would publish their birth certificate. That populated the SCADA system with all of the current data. So now I'm sitting there at T sub 1, and I've got all my data in the SCADA system. I know the state of every remote site. They're still there. They will tell me something, but if they drop offline, we're going to publish a birth certificate or a death certificate, and that will tell us that that particular site died. And we're going to take all of the tags that we have and we're going to stale them. So that was basically the first implementation at Phillips 66. And we saved them 90% of their bandwidth. 90%. So all of a sudden, instead of, so 90% of $2 million. The other thing we did is that before we started their round robin polling, it was taking them 15 minutes to get data from all of their booster stations, and command were taking upwards of a minute when you send a command. When we were done, we had all of their analog data were coming in every 10 seconds, and all of the digital data was coming in every 5 seconds, and the commands were sub 3 seconds. So the operator, you can imagine being an operator, now you had the real-time data coming in. And again, the premise is I've published all my data in, I'm quiescent. So all of a sudden the valve goes in transit somewhere, boom, that comes in. It's coming in less than 2 seconds. And that's how responsive the Phillips 66 SCADA system is. So here we are 27 years later. They're still running that original system that really needs to update it by now, but they're still running Oasis. It was Telvent, and then it was Valmet, and now it's Aviva, Oasis DNA. And if you look over the last 26 years, they've had 5 nines of availability, 6 MQTT brokers, everything out there. So it worked very well. Now, if we look at it now in 2025, if we look in hindsight, we let TCP/IP do all of our heavy lifting. We didn't do, and so some people read the MQTT spec and they look at it and they go, Arlen, you don't have security in your protocol. How can we use it? Well, TCP/IP takes care of that for me, right? I'm sitting on top of TCP/IP. So, I don't know what, 10 years ago, this thing called TLS came out. Well, as soon as we had TLS, we could sit right on top of that. So tomorrow, if TLS 3.0 comes out, we can sit right on top of that. So we get to take advantage of the latest TCP/IP security technology. The other thing that was kind of a flip of the coin at the time is that, remember, you've got this TCP/IP network, you've got an MQTT broker. I'll go put up a diagram here in a little bit, and you've got the clients. And we decided to make to where the clients would connect in remotely. They would all just come up and they would connect and start publishing data. Well, now in 2025, guess what? That's a zero trust security scheme. We're out at a booster station at one of your locations. We're going to come up, make an outbound TLS connection. You go do your security team goes out to the booster station. You have no ports open. No ports open. So that's really when I said, IT kind of, hijacked MQTT. That's why they all use MQTT for their IoT data ingest, is that they don't have the cloud companies don't have to go down in the plant or in the pipeline, and you have to open a firewall from the cloud into your facility. We didn't define any strict rules for how to use MQTT. So the way MQTT works is you have a topic and you have a payload. And the payload is a binary blob, and the topic can be whatever you want. It could be Arlen/foobar/CNX, and the payload could be binary Modbus, it could be JSON, it could be XML. And really, that's what's led to the adoption of MQTT. Right now, as I'm talking, there are probably anywhere from 10 to 15 billion MQTT connections. I think where it really started taking off is about 10 years ago, Facebook had a blog. And in the blog, they said Facebook Messenger sucked. And they were given the edict to make it more efficient. So they were looking around, they found the MQTT spec, they implemented it, and in their blog post, they literally, if you read their blog post, it literally kind of said, oh, it's simple, it's efficient, it's bidirectional, it's cost effective, and it's secure. And as of today, Instagram, Facebook, pretty much all of the BMW, Tesla. So if Andy and I had put a kill switch in MQTT and we turned it on today and all of that traffic was killed, bank ATMs would stop working, major pipelines would stop working, Instagram would stop working, Facebook would stop working, all of the AT&T infrastructure switching equipment would stop working. So really, it's incredible on how adopted MQTT is. And if you go back to it again, the spec is 18 pages. I got kids with Raspberry Pis in college that can write an MQTT client probably in half a day. So that's the other thing, is that now college kids are coming out, they're exposed to it, they know how it works. So we've got an attractor. If you look at, CNX, you go, hey, we're using MQTT, we're using the latest technologies. It's interesting now, really, if you go forward. And again, designed for real-time mission critical, but adopted by IT. So that means that now we've got a technology that college kids know, that IT folks know, that operational folks know, and now we can start leveraging that technology to make it do stuff interesting. So, Mike, no, you want to come up here? I'll actually do an MQTT demo versus PubSub. And can I have one more volunteer? Anybody else? Okay. Okay. So I'm a PLC out in the field. I'm on a pole response network, and Mike is the SCADA system. And what's your name? Nav. Nav is he represents the enterprise, right? Really, the enterprise wants the SCADA data, right? And so what's going to happen is Mike's going to poll me, and then we're going to see how that works. So now, well, so again, Mike's going to poll me. Did any of you hear that? Okay. Here's my point. Now, the same actors, right? And let's say that in this room, the air is the TCP/IP network. And since you got access into the room, you guys all have security, right? So you're secure. And now if I'm using MQTT, I come up, same PLC, and I can say 25 PSI. You heard that? You heard that? anybody else in here that's interested in that can subscribe to that, right? And literally, that's the difference between poll response and the enterprise getting data and publishing data securely and getting it out into a broker where anybody can subscribe to it. Thanks, Mike. Yeah. So that, again, it's just trying to get that into perspective, is that we've really, now that we've got modern IT tooling and stuff, poll response protocols won't let us leverage that. The way I look at it is that anytime you use poll response, you have a one-to-one connection, right? And so the machine that's polling owns that data. And if you want to get it out, it's hard. You can, and we've been doing that for the last 35 years, but we've created silos, we've created custom applications that nobody knows how to work anymore. We've created data swamps that people aren't using, and we've got to find a way to open up that technology. So to kind of go through this, schematically, so with an MQTT infrastructure, you have a broker and you have a client. That's how MQTT works. The client connects to a broker, but for it to be interesting, you really have to have two clients. And so very, very simple. What you do in MQTT is you have very simple verbs. You have a verb connect, you have a verb subscribe, you have a verb publish, you have a verb disconnect, and you have a verb ping. Basically 5 verbs. So I connect to that MQTT server. It comes back, says, okay, you're connected. And then this client on the right, it sends over TCP IP. It says, hey, I want to connect to you, broker, and I have to give it a certificate. Hey, my name's Arlen Nipper. Yeah, you can log in. And then on the left, that client subscribes to something. And a wild card is I'm going to subscribe to all of the data being published over this MQTT server. And on the right, that client's going to publish a message. And in the topic, it's going to say, hello, world. And then, quote, in ASCII, the payload is going to be hello from a client. Now, he's going to publish that. It's going to hit that MQTT server. He's going to look around and say, who has a subscription to this message? And looks over here at the client on the left. Oh, you've got a wildcard, so I will go ahead and deliver that message to you. And the nice thing is that this is all event-driven. It's all very quiescent. But then we've got to look at state. So let's go a little bit deeper in that. So the client on the left, within the connect message, I can give it a username, a password, and a last will and testament. A last will and testament is an MQTT message, actually a topic and a payload that the broker is going to hold on your behalf. So my topic is PLC 07 death certificate, and my payload is PLC 7 offline, and I connect with my last will and testament. Now, notice the last will and testament just kind of gets saved in the broker. So the client on the left, and I just keep, publishing and subscribing. I'm good, I'm on the line. Now the client on the left, he connects, and then when he's doing that, he subscribes to a topic called death certificate. And that's fine. Everybody's happy, we're publishing, we're subscribing. This could be information system, it could be SCADA, and all of a sudden, that network connection to that client goes away, and the broker detects that client is no longer connected. He pulls his death certificate and he publishes it to the client saying, hey, here's the death certificate, and now I know that PLC 7 is offline and I should take corrective action. And again, in SCADA systems, Ignition, Oasis DNA, I think Signet has implemented some of Sparkplug. You should then set all of the tags stale and say, these are last known good values, guys. They're not live values anymore. So we look at a basic architecture for SCADA, we've got an MQTT client over here on the right that may be in a PLC. It may be an edge of network device in front of a PLC, in front of a flow computer, polling for that information. It's going to connect to an MQTT server. Okay, I'm happy. I'm connected. Now I need to start publishing data. I need to subscribe to data. Now, why is he subscribing? Well, we're going to send him commands. So he needs to subscribe to his command topic. And now he's just going to happily start anytime there's a change in any of the process variables, boom, report by exception. Client on the left, he's going to connect, subscribe, and then all of that real-time data is going to him. Now I've got to come over here to do this one. I can do this. I have to get on my laptop to do this. So also, I'm just pointing out here, from that client on the left, anytime he wants, he can publish a command. So this is bidirectional. People, you get in your head, oh, we're publishing everything from the field. It's all report by exception. And then I'll get the question, well, Arlen, what about commands? From the very get-go, MQTT was designed to be bidirectional. Now, here's that one-to-many architecture, right? When I was doing the demo up here with Mike and Nav, is that now, simply with proper permission, I've now got a one-to-many architecture, not a one-to-one architecture. So that lets me add clients out in the field publishing information, clients subscribing to that information, and the most important thing I want to point out, for all of those clients, they don't have any ports open out in the field. They're all making a TLS connection into a single MQTT server on port 8883. So from a security footprint standpoint, the only thing I need to protect is one port, not 100 ports. So kind of a summary for MQTT is, typically when we replace a poll response system with MQTT, we get anywhere from 80 to 95% bandwidth reduction. I haven't found one SCADA system where that wasn't the case. And it's kind of hard to imagine, but think about all of the valves that you guys poll, all of the pump statuses. How often does a valve, it doesn't go open and close 50 times a day, right? So we're sitting there polling it. And so all of that data basically is saved when we're doing complete report by exception. As I explained a while ago, we get faster response times with report by exception. Literally, the response time is going to be how quickly you're polling your device out in the field. But we replaced all of a poll response system for Plains Midstream in Alberta, Canada. And the operators, the operating procedure, SOP, was they sent a valve open command, they would have a stopwatch. And they said if it didn't go in transit in a minute, call somebody out. And it went from that to the operators had to be retrained because they would send a valve command, and before they got their finger off the key, it would go in transit. So that really is the order of magnitude of improvement that you get over the same network bandwidth. I would argue bullet number 3, send more data over the same network. So in 1999, we saved Phillips 66 maybe 80 to 95% of their communications costs. But in 2025, I guess what I'm saying is that's 80 to 95% more data that's stranded in the field now that you could get in over the same bandwidth that you've got. You get one-to-many communications. You decouple your data producers from your data consumer so that now we don't have a SCADA system. Oh, well, I'm sorry, Mike, you can't have that data because I don't know how to get it out of my SCADA system, or I don't have a tool to get it out of my SCADA system. And that's been where we're constrained a lot in a lot of the digital transformation projects. we know we've got sensors out in the field, but it's all siloed in one of many control systems that won't talk to that next layer, that won't expose the data and won't contextualize the data where it's useful to enterprise. And I'll go through that in a little bit, but I'll go ahead and point it out here, is that if I'm talking to a Emerson flow computer out in the field, and I get the orifice material enumeration, it's a 2. So now we send it to enterprise, and an IT guy looks at it, it's a 2. What does that mean? Is that different than a 0 or a 1? So if you think about it, our systems are awash in enumerations. We bring all that data up, and a 1 in an Emerson flow computer means that the orifice plate material is Monel, and a 2 is stainless steel, and a 3 is carbon. But why don't we go ahead and explode that out at the edge of the network, single source of truth, so that when we get it to the enterprise, a mere human being can look at something and go, oh, I can understand that. Security, I already went through that. It leverages TCP/IP, TLS technology, and it leverages the fact that it's a remote originated connection, so we're down to no ports open in the field. Future proofing with easy migration. So the nice thing about MQTT is that in acquisitions, if you're acquiring pipelines, if you're selling pipelines, it's very easy to take an edge of network node and just repoint it to another MQTT broker, and all of a sudden going to another control system. And it's mature. It's been out there. I need to update this slide. It's been out there for over 27 years. I think if there was something wrong with MQTT, somebody would have found it by now. And it's a common base technology that can be leveraged by everybody. Whoop. I think you need the microphone. They told me I had to say that. No.
On the future proofing, like you said that it's easy migration from current systems to whoever acquires that system. But how about future proofing in relation to technology, right? So for new SCADA technology to kind of come in.
Right. Well, I would like,
how does that work?
We're getting there. And again, Ignition Edge is a very good proof point of technology migration. But I'll go back to my ultimate vision. My ultimate vision is that I don't need edge of network computers. I have PLCs, flow computers, devices that are literally coming up, and then they're publishing, because they're the experts, right? An Emerson flow computer should be able to just come up and publish data and say, okay, Arlen, that's meter run number 1 configuration, and that's your meter run number 1 real-time data. And you literally could bring a SCADA system up in seconds doing that. And it's starting to happen. ABB, the newest version of the ABB flow computer, you might know them as Total Flows. I'm up in Stillwater, Oklahoma, so I go to Bartlesville, and they are putting MQTT Sparkplug on all their new flow computers. So if you had a new ABB, you would need any edge of network compute. It would publish into a broker, and boom, you're starting to use the data. The same with Phoenix Contact PLCs, Opto22 PLCs, Wago PLCs, and hopefully one of these days, Allen Bradley will pull their head out, and they'll put MQTT on. Because really, it's more of a political battle between how much money they've sunk into OPCUA and the fact that MQTT is easier to implement than OPCUA. And I won't get into that battle right now. It's a whole nother webinar. But yes, we are getting there. I mean, the message is coming out. I should mention that I'll do that when I go through the Sparkplug specification. But I did want to mention that MQTT, if you're looking at, if you're concerned about it, it is a OASIS open standard, and it is an ISO IEC international standard as well. So MQTT wasn't something that Andy and I just threw out there. And I think the thing that from, people ask me, why MQTT has taken off. It's all those reasons. Simple. It's efficient. But the other thing is that Andy and I did our first version of MQTT. It took us about 4 months. We argued with IBM lawyers for 2 years to keep it open. And had we not done that, I wouldn't be here today. We wouldn't be talking about this. IBM would have just deep sixed it. But we did keep it open. And then the Eclipse Foundation picked it up, and they made the clients easy. Then the Raspberry Pis started shipping with Node-RED, which is an MQTT creature. And really, that's kind of where the technology has taken off. Okay, we'll start going into Sparkplug and unified namespace. This is my attempt at playing on Google Gemini to draw a picture. So that is the unified namespace for oil and gas. But anyway. Okay. I don't know, about 2 or 3 years ago, myself and Don Pearson, who's an executive with Inductive Automation, and one of the head marketing guys, we were going through Gartner. And Gartner wanted to find the magic triangle or magic quadrant of IoT infrastructures. And we kept arguing with them. And basically, the premise is that, well, you guys do SCADA. That's not IIoT. So we're going, huh? What are you talking about? And so the proposition is when you're looking at cloud technology, no matter which cloud technology you're looking at, I've been there. I'm sure you guys have been there. So AWS or Microsoft or Google comes in and go, look, guys, we can do this and this and this. And then me or Mike or Jeff, right? You in the back of the room, you kind of raise your hand and you go, well, what about our OT data? And the guy goes, oh, no problem. Oh, we'll just connect it like that. Oh, we have tons of tools, right? Well, the reality is when they say that, is that IIoT without SCADA is good luck. So when they drew that little blue line down to OT data, let's look inside of that little blue line. And you got to come into an adapter and then write a little bit of Python code. And from there, you got to probably go into a data lake and write some JavaScript. And from there, it's got to go to another data lake, maybe run another script there. And then finally, you get to your solution. And literally, this is what we're seeing is that you've got all of these cloud services wired together, and nobody knows how they work. And the IT guys that wrote those, they're not around anymore. Nobody knows how that works. So really, what it takes is that if you're going from an IT down to OT approach, I guarantee that will fail every time. And the approach is that the reality is that getting OT data out is difficult without the right tools. You've got to decouple. You've got to provide a single source of truth. And you've got to demonstrate a superior OT solution. So if I couldn't come in to which I've been in front of a lot of them, if I had to sit in front of your SCADA manager and I had to be grilled on how are commands going out and how is the security done and how fast can you get the data in, and if I couldn't do that better than a legacy poll response system, then what's the reason I'm upgrading? There's no reason, right? So you've got to be able to show all of those. And then once your OT infrastructure is that mature, then you talk to IT. Because now you should be able to plug into many different types of IT architectures. And then from a data ops standpoint, we've got to get to the point where we don't have this mindset of PLC registers or flow computer TLPs or AARs and look at it in a more informational standpoint. So remember what we used to do is we had Modbus and we'd have register 40,001 would come in And then we had a database, and we would edit that, and 40,001 equals suction pressure. And then we gave it engineering high and engineering low. And literally for every point that came through, we had to edit that. But we're still not there yet, because now we have these SCADA screens where all of the process variables are hitting the data screen. It's organized. I know where it is. I know it's line 1. I know it's booster station 1. I know it's PLC 1. And then that organizational data falls off on the floor. Boom, gone. Because if it's going to like a Pi database or to another type of time series database, that time series database doesn't have the context, right? It's just got the value and a timestamp. There's no context to it. Probably you could go to Pi and pay them millions of dollars, and they'll give you another tool where you can retype all that data in again, so that now when you go read that tag, you've got context to it. So that's really what, on top of all of this, we need the notion of a data ops tool where we can start managing our data, give it context, start being able to do models of our data. So instead of a pressure value, we have a pump model. And then that pump has suction pressure and case pressure and discharge pressure and, temperature and all that. But it becomes an object that we can deal with. Because I feel like today what we're doing is we have all of this contextual OT data. It's all muddled up. So Humpty Dumpty fell off the wall. We send Humpty Dumpty to the cloud. And then we have a lot of IT guys that work a lot of hours to put Humpty Dumpty back together again, when we actually knew it in the first place back here. So that's that notion of single source of truth, one time, and then don't touch it again. So the great thing about MQTT is that you can publish anything you want on any topic. It's super simple. It's secure. But the bad thing about MQTT is you can publish anything you want on any topic. So when we first came out with MQTT, we started going to conferences and stuff like that, and everybody, we do MQTT, and we do MQTT, and we do MQTT. But the problem is, none of us did it the same way. So there was no interoperability. So about 7 years ago, myself and a lot of the guys at Cirrus Link, we sat down, we took about 6 months, and we wrote a specification that said, hey, lessons learned over the last 20 years, best practices. If you're going to do this, this is probably a good place to start. And that turned into a specification called Sparkplug. So Sparkplug is nothing more than a spec that says, if you want to use MQTT in a mission-critical real-time environment, this is probably a good place to start. And it does 4 important things. The first thing it does is it defines a well-known OT-centric topic namespace. Now, if I know a namespace, I can go in, I can do a wildcard subscribe, look at the data coming back, and I can tell you where it came from, I can tell you the context of it, and I can tell you what's going to be in the payload. And the result of that is plug-and-play auto-discovery. So this afternoon, I'm going to show you that. I'm going to show you we're going to have edge of network devices connected to flow computers, and we're not going to know anything about those flow computers. We're going to connect into the MQTT infrastructure, and in less than a second, we're going to learn all of that automatically, i.e. plug and play. Second thing that Sparkplug lets you do is we can publish a model from the edge. So again, that goes back to this notion of data ops, is that if I had equipment at the edge and I could define a pump UDT or a pump model or a tank model, maybe I have my tank, I have my interface level, I have my temperature transmitter, I have my high and my high and low, and that all becomes an object so I can use it again and again and again. With Sparkplug, I can publish that template definition from the edge, and then those instances of those, the actual instances of those models, we can publish those as well. So again, this afternoon, I'll show that we're going to create a model at the edge, publish it up to a central SCADA system, taking that same model and publishing it to Snowflake. and never touching it. So our single source of truth started out in the field where all of our subject matter experts are, and it was never touched on the way through. And that's a problem with a lot of our SCADA systems is we don't know what the single source of truth is. We don't know where that came from. Oh, Joe, it's over in that database. Well, where did that database come from? Oh, we don't know, but we think there's some data in there, right? Third thing, once I've got a process variable, I want to know its timestamp. I want to know its name. I want to know its engineering high, engineering low, dead bands, and any other data that you want to associate with that measurement, custom data, and have that saved in like something like a time series database, in Ignition, in Snowflake, things like that, so that I've got a well-known definition, not oh, Arlen, it's 40,001. Well, 40,001, I know, but what's the engineering high? What's the engineering low? What's the dead band? None of that, right? We have to have contextual data when we get this up to the enterprise. And then lastly, MQTT defines state. Remember I told you that we can register that death certificate? Well, we standardize what that death certificate says so that when we do publish it, all of the people interested in my data can subscribe to a well-known death certificate so we can manage state of our MQTT connections. Now, subsequently, the Sparkplug spec, we basically gave all of the IP to the Eclipse Software Foundation. They're one of the largest open source software groups in the world, and they manage the Sparkplug spec. And just like MQTT, we now have ISO, IEC, international standardization around the Sparkplug spec. And the other thing that's very important is that we have a TCK for any vendor that claims to be Sparkplug compliant. They can download free software, run their implementation just to make sure that all of the requirements are met so that we have interoperability between vendors out there so that ABB works like Emerson, works like WAGO, works like Opto22, works like Ignition. So the way I look at it is that the Internet of People really exploded with two open technologies. First, there was HTTP. And if you're old like me, you know, there would be bulletin boards you could get on, and it would have like a text menu, and you could like maybe download files and stuff. And then a company called Netscape came along, and they go, oh, well, what if we had define what was over that HTTP? We'll call it HTML. And they're both open standards, and the Internet of People exploded, right? So we need the same concept within the industrial Internet of Things. We have basically a dominant transport layer called MQTT, and now we have Sparkplug on top of that that gives us context of what's in those MQTT messages that we're publishing back and forth. So just kind of give you a view of, from our perspective, you know, where we sell MQTT technology to. We have well over 2,000 individual separate companies that are leveraging MQTT Sparkplug technology in their infrastructure. It's interesting, if I would have shown you this graph probably 7-8 years ago, that would have been probably 95% oil and gas. And it's still a growing sector for us, but now all of these other sectors are coming in. We found out just the other day that data centers that they're installing all over, they standardize on MQTT. I didn't know that, but they did. So now all of the data center infrastructure out there, we're getting a lot of leverage into that because they're all using MQTT to basically monitor all of the server racks and the cooling system and the electric system and everything going into a data center. So switching over a little bit from MQTT to where we use it, especially from a commercial standpoint, I think you probably all have heard about Ignition. It could be SCADA system, it could be HMI, it could be alarming, it could be reporting. But the way we look at it is that it's a tool for enterprise connectivity. So with Ignition, I've got OPCUA, I've got Modbus, I've got Allen Bradley. I can talk to HART protocol converters or HART 420 milliamp transmitters. And I can get all that raw data into the Ignition platform. Now it's all raw data, but I've got a tool to be able to start creating data models. And once I instantiate those become the word I hate, which is digital twin. But if you think about it, they're digital twins the way that you, CNX, use them. Not the way that Microsoft thought you ought to use them, not the way that AWS thought you should use them, but those are digital twins the way CNX wants to use those for their enterprise. And they can change, they can morph, they can be adapted to your business practices. So if I look at MQTT, if I look at Ignition, it's got all of these protocols out of the box. One of the member companies now added HART to the mix, so we can talk to smart 4 to 20 milliamp devices. So the pressure, temperature, Coriolis flow, pH, control valve, valve positioners are all talking the HART protocol, which we've kind of forgot about over the last 25 years since it was invented. But we need to start getting out there and getting into that, because there are probably 150 pieces of information inside of a HART smart transmitter that you would be interested in. So if you have a pressure vessel and you've got a Rosemont pressure transmitter on the top of it, you would probably like to know the body temperature of that to see if you're cooking the smart transmitter up on the tower. So that's the primary, secondary, tertiary, quantitary process variables you can get out of a smart transmitter if you've got the interface into that. So we've got all these protocols. We can build UDTs out of that. We've got all of the UDTs now. Ignition, we've got the data contextualized. So we look at the MQTT transmission module that Cirrus Link developed. So what we do is take that Sparkplug spec, we take that data out of Ignition, and we build those Sparkplug templates, and we publish those to any MQTT broker. It could be Chariot, it could be HiveMQ, it could be EMQ, it could be Mosquito, any 3.1.1 compliant MQTT broker. Now, what we do with that, we don't care. So somebody can subscribe to that, but you can see the decoupling. We're just publishing, right? We're not constrained by the applications that might consume that data. But in what we'll go through this afternoon is we're able to take that data, publish it from edge of network. So we can build a model at the edge. We can publish that up. That model is then instantiated within Ignition. Now I can start building my screens. I can do alarming. I can do reporting. I can take those to a time series database. And then you've got all of that. And then the enterprise comes along and goes, hey, we want to take all that data to the cloud. We want to run LLMs on it. We want to do anomaly detection. We want to do machine learning. And it would be really nice if we didn't have to write a single line of code to take all of that contextual data and get it replicated in Snowflake. And that's what we'll go through this afternoon. You don't have to read through all of that, the fine print, but really the unique thing about Snowflake is that when we first started working with them, they didn't have an IIoT platform. So if I go to AWS, they have their site-wise tools they want to sell you. And they have their own digital twin. And it's not the digital twin the way that you guys want it. And if you go to Microsoft Azure, they have a IoT digital twin, and it's not the way that you guys want it either. But when we went to Snowflake, they had no IIoT service. So we literally got to take Sparkplug data raw right into tables, SQL tables in Snowflake. The other big problem, if you look up here, at the very top, you can see that I've created a digital twin using what everybody else does for a digital twin. And they have a Boolean, and a 32-bit int, a float, and a string. But I've got customers that have PLCs with floating point arrays. If you've got a float computer out there, you've got 64-bit longs. If you've got any sophisticated reporting, you're probably publishing data sets. So the nice thing about Snowflake is that for all of the 20 data types that I can create in a sophisticated ignition SCADA system like Ignition, they natively flow into Snowflake. So I understand all of those data types. Whoop. Oh, that's the end. So I really like that, the most profound technologies are those that disappear. And I think, I've been doing this for 46 years, and we haven't done a very good job in making SCADA just kind of disappear and just work. But hopefully with this kind of technology, we can start looking at it from that standpoint. So with that, I'll open it up to any questions. We can go back to any slides. Anything you guys want to ask? Yeah. Sparkplug A is out there. What we did is there was already a company called Eurotech that had published a protobuf schema that already had some data types in it. We thought, it'd be good to follow one that's already in public domain. But our oil and gas customers were very quick. The feedback that we got on Sparkplug was tremendous from the oil and gas companies. And we quickly realized that the data type definitions and the ability to expand schemas didn't work very well. So we kind of immediately switched to Sparkplug B. And really, we haven't had to touch that in the last 6 years. Any other questions?
So how do you walk through, or can you talk through single point of failure with your broker? Like, what do you do for redundancy?
I got a slide on that, but let me see if I can talk through it. So so when I worked for Coke, and then over the years when I built protocol converters, we had all of those serial lines going out polling, right? And if we had an emergency system, we had to take all of those circuits and get them back over and get them back up and running, and then repopulate the data in the SCADA system. And, redundancy switchover was hell. But with MQTT, you have 2 brokers, or 3, or 6, like Philips. And what happens is that your SCADA host application connects to all of them. Okay, so I'm a SCADA host. I've quiescently got connections to 6 brokers for Phillips 66. The field devices out in the field, they connect to any available broker. Okay? Now, if I get rain fade, so Phillips 66 was unique. They had primary, secondary, tertiary, so they had VSAT, cellular dial-up. So out in the field, if they got rain fade or one of the VSATs, our MQTT connection would drop out. We'd get a death certificate back at Bartlesville. All of the tags would go stale. In the meantime, this guy would switch to cellular. He'd connect to another MQTT broker, publish his birth certificate, and everything is back up. So that is the single point of failure. So you can have as many brokers, and I think, again, that's why I mentioned Philips has 5 nines of availability, because they had 3 network paths out and they had 6 MQTT brokers.
Enough to know which broker to go to at what point in time, though?
Doesn't care. Because remember, I'm MQTT, I get a message coming in. I don't care which broker it came from. And with Sparkplug, I knew where it comes from, and I know the data that's in it. That's even better.
All right, thanks.
You're welcome. And I've got a couple diagrams that maybe this afternoon we can get together. I can go through that. But literally, it's just the fact that failover, when we did it at Phillips 66, it was just so easy. We just have multiple brokers. And I want to point out one other thing is test and so you've got your production SCADA, right? And it first dawned on me, So at the time, Phillips 66 was using the Oasis DNA, and Valmet were in Calgary, Canada. And so the next version of Oasis DNA was coming out, and Valmet said, okay, we need this much money. We're going to set up everything in Calgary. We're going to, do a fake point-to-point test. And Steve Koenig goes, no, you're going to connect to our MQTT broker and get live data. And that's the cool thing, is you can have test and dev running on the same MQTT infrastructure. The only thing for test and dev is you disable the commands, so that with test and dev, there's no way you can send the command out. And I haven't gone through the access control list, but with an access control list on a broker, you can specify who can subscribe to what and who can publish on what. Any more questions?
I have one, Arlen. The question I have is, that, I have a saying. I've put 7 kids through college, and the saying for me is that your dreams are only as big as your bank account.
Yeah.
And I know later on today, you're going to be doing a demo with Snowflake. But in your experience, when you're talking about Azure or AWS, what's the business case for Snowflake? Because sometimes that could be at top of mind if you're in a leadership role at CNX, or you're saying, hey, there's some dollars here.
Mm-hmm.
In your experience, is there, I recognize that Snowflake looks simple. But in your mind, in your experience, and maybe you'll allude to this later, but can you describe maybe a short business case where, hey, this actually makes sense?
Well, yeah, I can, and then we'll go through it later again this afternoon. But with everything that I've seen with AWS and with Azure, kind of the first products that we came out with, and we have injector modules, so we can take an Azure injector and we can inject data into a Microsoft data lake all day long, and we can inject data into an S3 bucket all day long. But remember, that's raw data. You got to have somebody write code to take all of that and put it back together again and contextualize it. The advantage with Snowflake, and I'll go through it this afternoon, is that Snowflake is just a SQL database on steroids. And what we do with Snowflake is the Sparkplug data comes in, we land it in a row, we can look at that and go, that's a birth certificate. Oh, great. I'm going to go pull out all your UDTs. Oh, there's a pump, there's a tank, there's a compressor. Okay, well, now we know about the models that are in there, and then all of the D data messages flowing in, we can populate tables in real time. And now we've got that, we can set a Lambda, an LLM on top of it. We can put machine learning on top of it. And the nice thing with Snowflake is that your data never moves. The predictive maintenance, AI, ML just sits on top of your data in Snowflake. And again, it's contextualized. So you'll see this afternoon, I'm going to have a UDT coming from the edge of the networks. It's coming into an ignition, and it's going to Snowflake, but it's still the original UDT that was defined out in the field. And then if you change it over time, then that'll be reflected and be republished. You'll always have a single source of truth up in Snowflake. And the cost, again, I guess, yes, putting raw data into S3 buckets is simple. But then how many IT people are you going to have to hire to take care of that data long term? So I think if you kind of did a cost analysis on the whole thing, I still think Snowflake would be cheaper. Say that again? Yes. I mean, yeah, I probably have 60, 70 customers on Snowflake right now that are doing exactly what you guys are doing. You're taking SCADA data. And again, a lot of it's manufacturing data. We have server farms, we have food and pharma. We've got Chobani yogurt. We've got graphics packaging, which is kind of cool because if there's any paper, like the Starbucks paper cups out there, those are made by graphics packaging. And I bought a Mentos gum, and now it comes in a cardboard container. And I looked on the bottom, it's graphics packaging. So Doritos packaging, just crazy number of packages those guys do. But yeah, it's been very interesting. And they use the heck out of Snowflake.
So we're currently using Snowflake, and I understand a lot of the pros and cons of Snowflake, but in my experience, Snowflake isn't really a performant time series real-time database. Are you guys using it in that aspect, like writing directly to Snowflake real-time, having that data available within 1 second, and instantly querying, huge tables?
We can, well, so far what I've seen, the performance, so what we're doing is we're going through Snowpipe streaming. So that's basically free ingest into the SQL table. So we call that Sparkplug raw. Okay? Now, right now, as default, we're going down and we have a stored procedure that looks for changes going into that Sparkplug raw table, and then we percolate those up into the table views that you know about. So right now, that latency is about 5 seconds.
From source to get into Snowflake with Snowpipe? Okay, because I've seen numbers more on the lines of like 1 to 2 minutes.
No, it's pretty much real time. And we could do it faster, and there you go. I mean, then it's how many warehouses do you want to spin up to get that data in at that speed. But what we're using is an extra small warehouse getting the numbers that I was just telling you about.
And what are like the sizes of those tables? Are they pretty small tables, or are they just...
They're views on a very large table. All of the Sparkplug data is going into one Sparkplug table.
Okay.
So what I'll show you this afternoon, there are views that the stored procedure will pull out for you, knowing that the data in the big raw Sparkplug table is formatted in Sparkplug, so it knows how to go find, pipeline 1, booster station 1, PLC 1, tank level. Boom. Right to it. And that's the thing, is that's already been contextualized for you. So you literally can go and look, and basically that's the concept of a unified namespace. So you have enterprise site area, cell device, and if you kind of follow a unified namespace, then when you get it up in the Snowflake, as long as you know how your company names things, you literally could go right to the information.
Okay.
But yeah, if you've used Snowflake, again, this afternoon pretty much will be all about that. So, man, let's go, we can
I guess
poke
I'm
around
just
in it.
Curious of there's a lot of time series specific databases, like InfluxDB, Elasticsearch, that are optimized for time series data, high performance querying. And I really haven't seen a lot of information that shows that Snowflake is up to that level of high performance analytics. I mean, I'm sure, it can fit the needs for the bulk of applications, but I'm just curious, what is the point of these high performance time series databases if Snowflake can handle everything?
Well, that's a good point. But I would argue if you look at, most of the drivers that I've seen for like InfluxDB and all that, you're taking a single variable so you have temperature, pressure, RPM, blah, 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 blah. But you don't have the entire contextual tree that got down to that. You've got to know where it came from. The nice thing I like about Snowflake right now is that we're laying it in contextually, but if I go to a row and to a column, that's all real-time data. So I kind of get both. I get the structure of me knowing what a pump UDT is for CSX at one of its remote sites. That came in contextualized, but we're also, and Snowflake is doing more and more on giving you the time series features like lead lag and things like that within the SQL language that's in Snowflake.
Okay, well.
And I definitely can get you in touch with Poogle Janamakaran. he is the CTO for basically for IoT data into Snowflake. And him and Venkat and some of the experts I've been working with would love to answer your questions on that.
Okay, thank you.
Arlen, I guess just a quick comment first and then a question for you. So you kind of touched on before, you mentioned about Allen Bradley, right? And so just to kind of bring you up to speed a little bit, I don't know if you're aware of it, but they have an add-on instruction that you can actually bring into your PLC and connect to. It's a non-secured broker. You cannot bring in a certificate. So unfortunately, so they are kind of starting to get, into the MQTT.
Yeah.
They also have an optics module for control logics that you can put into your chassis, and you can actually set up a broker. And we haven't got one of the cards, but I kind of would like to get one to play around with it. So just a quick little
I would love to
from
do
Allen
that
Bradley.
because
So
even with that, with Ignition Edge, then you could bring that MQTT. So there's a broker right there. You could bring that right in, and then now you could contextualize it with a UDT. Okay.
exactly.
That'd be awesome.
So just
Yeah.
want to let you know about that. And then just a question for us. So we use brokers really basically for sending data from like Wonderware to Signet and, just kind of sending data back and forth. One of the things that we've always kind of been leery of is like using it more from a control standpoint. So I guess, like what are some best practices or some things like from using it from a control standpoint, like where, like if we're going to try and automate a process, like where we have to start a pump, stop a pump. And I guess one of the other things too is like we typically use either JSON format rather than Sparkplug, or like just like a hard, like a hard coded value. So I guess like is Sparkplug preferred? And if you're using a different format than Sparkplug, is there like certain, best practices? I guess.
So I can't speak to Wonderware or Signet. That I don't know where they're at in their journey, but I'll go back to the original system. Is that myself and John Lujan wrote the C code for the Omnicom, which is the Signet, the Oasis DNA. But anyway, long story short, as long as you've got, the format of your data, so you've got known good data coming from your remote sites, you've done your point-to-point check, and that data is flowing in, then Sparkplug defines a D command message, right? And so a lot of people, I do talks like this, Arlen, there's quality of service 0, quality of service 1, quality of service 2. Quality of service 1 and quality of service 2 were for IT. Never use anything other than quality of service 0 for command and control. Because I don't want to send a valve open command today and have it show up tomorrow, right? But as long as you're publishing everything quality of service 0, and then they go, well, Arlen, how do I know the command got there? I guarantee you, Signet, Wonderware, Ignition, Oasis DNA, Aviva, blah, 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 they all have command disagree capabilities built in. So if I send a valve open and it doesn't go in transit, I'm probably going to get an alarm somewhere in my system, right? A command disagree. So it's all built in, really. But it's having, JSON. I love JSON, but if at some of these booster stations that like Chevron, Exxon have, I can't take 10,000 tags and publish those JSON. It would kill the VSAT system would just fall over. So Sparkplug, if you want to know, the protobuf encoding that we use. So everything we do in our code, it's all JSON, and then we run one line of code to compress it into protobuf. Then on the other end, if you had any other applications that wanted to consume Sparkplug data, one line of code can take the protobuf and push it back out into JSON. So we argued about that. It was a fine line. When we did Sparkplug, we didn't want to lose the lean and mean capabilities of a binary payload of MQTT, but we wanted to make it humanly understandable. So Sparkplug kind of went down the middle of staying very efficient, but yet being able to be understood by people that were writing code.
Thank you.
Yeah, you're welcome.